Okay, guys, let's try and get through this next section. Probably take us 2 videos, but this will kind of end the second section of the notes for us. So some definitional stuff. You probably have heard these before, but whether we remember them or not is another thing. So we got the empirical formula here, and then we got the molecular formula. So what I want you to remember, empirical formula is what you're used to. That's simplifying things and reducing them. And so what you want to write in that first blank is that the empirical formula, right in this blank here, is the lowest whole number ratio. It's the lowest. That's what you want to write in that first blank. And then the next 2 blanks says empirical formula is the lowest whole number ratio possible. And then here it's ionic and then compounds. Ionic compounds are empirical formulas. So what the heck is an ionic compound? Well, ionic compounds are anything that uses a metal. And so a metal and a non-metal are going to make those ionic compounds. So let's say you had like chromium and oxygen, then that's ionic. Or if you had calcium and oxygen, that's ionic. And so metal, non-metal makes ionic. That's what you guys were used to last year. And those are things that you guys would be reducing. So that's what you've done. You just may not remember it as having a specific label. So empirical, we want to think of those as simplified. And then the new one, the molecular, we want to think of those as not simplified. Okay, so we got simplified and not simplified. You might want to write those in the margins. So, okay, we're going to take a look at this example real quick. And I've written at the top for example 6 that empirical is reduced. So I want you to pause the video. I want you to look at 1, 2, 3, and 4 and see if you think you can reduce them or not. Okay, so hopefully you've had some time to look at it. You have decided if you could reduce them or not. And I'm going to show you whether you can reduce them or not. So we're just going to start here with this first one. And C6H6 can be divided by 6. So C6H6 can actually be reduced to CH. So that is not empirical. It's actually what we would call molecular. Okay, C3H8, I cannot reduce it. It is in this position. It's always going to be in that ratio, because the C3H8, they cannot be reduced. I can't divide by 2. I can't divide by 3. So that's as low as it gets. N2O4. Well, hopefully you figured out you could divide N2O4. You could divide them both by 2, which would give you NO2. So that's a no. That's a molecular. And then this guy here, this is a keeper. That's empirical because you can't divide the lead, because the lead is only one lead, so you really can't reduce it any farther than 1. So that's kind of a bit of a clue. If you see a single element in a formula, then it's probably going to be empirical because, I mean, it's logical, right? You can't reduce it below that value. So, okay, we'll practice some more on that in a little bit. Now we're going to do an actual problem here where I'm going to actually work through a math problem with you. And so the key thing on a problem like this is right here. They're asking you to find the empirical formula, but look, they give us this mathematical data, these percentages. So the first thing we're going to do is the percentages are out of 100. So we're just going to assume that they are the same as grams. And so 37%, it's always a problem for students, but 37%, well, it's out of 100. So we can just basically eliminate the percentage sign and just replace it with grams. So 37% is going to be the same as 37 grams. No conversion, you just swap out the unit. Okay. All right. So I'm going to slide over. I need a little more space on this one. So I've started it over here. And so you guys are going to see that I have started this problem, and what I'm doing, and this is step number 1, you're going to want to write this down somewhere. So step number 1 what we're going to want to do is we're going to convert to moles. You convert everything to moles because in chemistry, things don't work super hot if they're not in moles. So that's the first step. I've already done that. And you can double check me. You can look, but when you look up carbon on your periodic table, you're going to quickly find that the carbon is 12.01 and there's the nitrogen 14.01, etc. So that's where I got those values. I'm not making them up. They just came from the periodic table. So be aware of that. So I've got this set up where all of these chemicals are being converted into moles. So the carbon, the hydrogen, the nitrogen, we're converting them all over. And so if you look, we can cancel out the grams on all of these top and bottom, and that's going to give us what we want, which is moles. So what is the goal of this problem? Well, the goal of this problem is right here, to create or determine the formula. So see right here, we're supposed to figure out the formula. So I need to figure out, well, how many carbons? Like what would go here? How many hydrogens? How many nitrogens? How many oxygens? That's what we're doing. Okay, so first step, we're converting everything into moles, and then we're going to do a little math. So let's run these through, pause it, run it through, see what you get. I want you to make sure that you don't mess this up, though. Don't make that mistake. All of these are going to go to 3 sig figs because these all have 3 sig figs. Remember the conversion factors over here, those guys are not used for sig figs, just the front. Okay, so 3 sig figs and also pause it. Go ahead, run through and see what you get. Okay, hopefully you got these numbers. I'm going to write them out. You hopefully rounded correctly. So we would get 3.08 moles. We would get 2.18 moles. We would get 1.32 moles. And the last one we're going to get is 2.64 moles. Okay, so those numbers are not what we want to use because we need to get rid of the moles. Like we don't need the moles. We need that to be gone. We got to get rid of that. So here's the trick, and that's what students always forget. So we're going to go ahead and write it down. Step number 2 is going to be divide by the smallest. So we're going to divide all of your numbers by the smallest value. This is the step students always forget. So if I were you, I might put a star or highlight that or whatever, because if students miss this problem, it's because they forget to do this. What they try to do is they try to take these and round them, and that's not correct. You have to first get rid of the moles before we can do anything else. Okay, so I'm going to go ahead and do that real quick. I'm going to divide them all by the smallest, and the smallest is the 1.32. So that's going to be divided by 1.32 moles, and then you'll see that the moles would cancel there. 1.32 moles, and you get the picture. Off we go. All right, now you guys can go ahead and run that through your calculator, see the answers that you get, pause it, and then I'm going to write in what I got. Okay. All right, these are the answers that you guys should have gotten. You should have gotten 2.33, 1.65, 1, and 2. All right. So these numbers are interesting, but I want to point out to you that it would not be great to do this. This would not be awesome to have like carbon 2.33, right? That would be kind of weird. Hydrogen 1.65. Like that's not going to work. We're not going to want to do any of that. So what we have to do is figure out a way to get the whole numbers. Now you could round, but here's the problem with rounding. These values, that's too much to round. That's too much to round. Now, if it was like a tenth or less, you could round it, but that's too big to round. So if it's over a tenth, you got to find what we're going to call a multiplier. And you're going to multiply them all by a number that gets them to a whole number. So if you have halves, 0.5s, multiply by 2. If you have thirds, which we have a third and 2/3, multiply by 3. If you have 0.25s, quarters, multiply by 4. So this is a third, and that's 2/3. So we're going to multiply all of these, and this is the key, all of them by 3. This is not always required, but in this case, we've got to get to the whole numbers. And so when we do the math, you're going to get, and we're going to go ahead and run this through our calculator. So 2.33 times 3, and you're going to get this 6.99. And see, that's close enough that we can go ahead and round that to 7. See, that's within a tenth. 1.65 times 3, that's 4.95. Once again, close enough to round to 5. You don't need to round that because it's a whole number. And then 2 times 3 is 6. So what do I do with these? Well, they become the formula. So see, over here, we're trying to create this formula. And so the formula, and let me get a different color here. The final answer is going to be those numbers next to those chemicals. Some of them come down here. So it's going to be carbon, and the carbon is going to get a 7. Then it's going to be the hydrogen, and the hydrogen is going to get a 5. Then it's going to be the nitrogen, and it's going to get the 3. And then last is going to be the oxygen, and it's going to get a 6. Now, I'm not just making these up. These are the things that we just came up with, right? So that they are right here. So the 6 goes with the oxygen. The 3 goes with the nitrogen. The 5 goes with the hydrogen. And then the 7 goes with the carbon. So that's where that's coming from. So your final answer is not a number. Your final answer is this formula down here, C7H5N3O6. All right, so that is how to solve it. Now, example 8 is what I want you guys to attempt to do on your own. Now, I'm going to work it in the next video, but I want you to try to do it on your own. Okay, in class, this is how we do the learning. I do some stuff, you do some stuff. All right, so you guys take a look at that and see if you can come up with the answer for number 8.